The purpose of this video is to describe the creation of the centripetal acceleration formula plus the centripetal force formula. If we take our circle in the upper left-hand corner, we can see that we have an object traveling in a circle with radius r, and it's traveling through an angle theta. As we look at angle theta, we can see that it moves through a sector S. However, as that angle approaches 0 degrees, we can see that the sector approaches delta x, where those two become equal. We can also then look at the idea of the delta x over r then being equal to s over r as a ratio. If we then look from our kinematics at delta x equals v delta t, or our change in position equals our velocity times our change in time, we can see that that will also equal our s. Moving to by substitution, then we can see that v delta t over r is equal to s over r. Moving on to our velocities in the upper right-hand corner, we can see that we want to find our change in velocity. And our change in velocity is the difference between v2 and v1. In this particular case, we will call v2 red and v1 green. Because we are finding the difference, we want to add the opposite of v1 to v2. Linearly, this may be a little easier to understand. If we take our green to be v1 and our red arrow to be v2, we can see that when we want to find our change in velocity for these two, we take v2 minus v1 and we get the difference, which is our delta v. By applying that to a nonlinear transformation, we can see where v2 minus v1 equals our change in v. We can also see that our delta v over v is a ratio similar to our s over r. Because these are similar triangles, we can now set them equal to each other. So s over r is going to be equal to delta v over v. By substituting, we can see that s equals v delta t over r, which also equals delta v over v. By moving our delta t to the bottom on the right and our v to the upper left, we can see that we get v squared over r equals delta v over delta t. From our kinematics, we know that delta v over delta t is equal to our acceleration. Therefore, v squared over r is going to equal our centripetal acceleration. Likewise, if we invoke Newton's second law, F equals ma, where we want to talk about the centripetal force equals mass times the centripetal acceleration, we can see that Fc, centripetal force, equals m v squared over r. Graphically, if we take m on our x-axis and f on our y-axis, we can see that that is going to produce a linear line. If we then take v and f, we can see that this is going to create a quadratic, or a parabola. Finally, if we take our radius and our force, we should see that it's going to form an inverse curve. And this is the theoretical creation of centripetal acceleration and centripetal force.